Good day, grade 12s. Let us continue solving more problems on questions of conservation of linear momentum. Before we begin, remember that when you have two objects, you start your calculation by writing the sum of initial momentum equals to the sum of final momentum, or you can write it as this one. Total momentum before equals to total momentum after. Remember also that we have three scenarios. Just read the questions carefully whenever you have to solve questions. Let us begin with the first one. It says here, I hope it's visible. It says a ball of mass 0.16 kilogram moving east at a speed of 10 meters per second collides head-on with another ball Q of mass 0.2 kilograms, which is moving west at a speed of 15 meters per second. After collision, ball P moves west at a speed of 5 meters per second as shown in the diagram below. Ignore the effects of friction and rotational effects of the balls. So we have, before collision, we have, this is almost like our the summary of the data. Just to add on it, this is the ball P is 0.16 kilograms and this one is 0.2 kilograms. This one is moving to the right, this one is moving to the left. Question number 1. Define the term momentum. Remember definitions. We say that the definition of momentum, it's actually a formula. It's the formula that says P is equals to mv, but we have to say this in words. So we say momentum of an object, it is the product of mass and velocity of that object. So the product of mass and velocity of the object that is the definition for momentum. Let me remind you, this is the definition we had yesterday. Momentum is the product of mass and velocity of an object. So for 2 marks. If you write that, you get 2 marks. Now 4.2, it says calculate the velocity of the ball Q after collision. 5 marks for 5 marks. For us to be able to calculate the velocity of ball Q after collision, we need to engage the principle of conservation of linear momentum, which says that the total momentum before collision is equal to the total momentum after collision. Then we write, remember the scenario we have. Before collision, the two balls are separated. They collide head-on, then after collision, they move as separate bodies. So it means that we have momentum of ball P M 1v1 initial plus the momentum of ball Q m2v2 initial. So this before collision momentum of ball 1 plus momentum of ball 2. This equals to after collision the momentum of ball P. So m1 v1 final plus momentum of ball Q, which is m2 v2 final. When you write this formula, you don't choose direction as yet. You wait to substitute your signs in when you put in numbers. Now we need to choose the direction that we are going to take as positive. We can choose west as positive, or we can choose east. In this case, I'm going to choose east as positive. So it doesn't really matter which one you choose. Just remember, when you look at your after calculations, check your answer and write the correct direction. So let's substitute the values. The mass of ball P is 0.16. The velocity of ball 1 is to the right, 10 meters per second, so it's 10 to the right, is positive. Plus mass of ball 2 is 0.2, and the velocity of ball 2 is 15 meters per second to the left, so it's opposite what our choice of direction is positive. So this will be negative 15. Also remember, don't make mistake and put negative on the mass. The mass can never be negative. It's a scalar quantity. After collision, the mass still remains 0.16 for ball 1, and the final velocity is 5 meters per second to the left, so it's going to be negative 5 plus 0.2 multiplied by final velocity of ball Q, which we don't know. Then we're going to do the maths on the right hand side. and on the right hand side, so we calculate 0.16 multiplied by 10 plus you open brackets 0.2 multiplied by negative 15. So on the right hand side you will have negative 1.4, which is equals to, on the left hand side you have 0.16 multiplied by 5, negative 5, and you have negative 0.8 plus 0.2 final velocity. Now you transpose 0.8, you don't add the 2. This one is 0.2 final velocity, this one has no final VF on it, so you can't add the 2. You need to transpose this one. This one has to go to the other side, so it becomes negative when it positive when it goes this side, so it becomes minus 1.4 plus 0.8 equals to 0.2 V final. Always when there's an addition or subtraction sign between two numbers, you move one that does not have a variable to the other side, and it changes the sign. So here we have negative 1.4 plus 0.8. You get negative 0.6, which is equals to 0.2 V final. The final step, you divide by both sides by 0.2, because now there's a multiplication sign between the two. 0.2 divided by 0.2, 0.2 cancels 0.2, and on this side 0.2 goes 3 times 3 meters per second is the final, negative 3 meters per second is the final velocity. So let us write it as final velocity is equals to 3 meters per second. It is negative, right? So negative means that it's going in towards the west direction, so we write west. Whenever you're calculating the value of a vector and they did not say calculate the magnitude, please include the direction as well, because you get a mark for that. And this is how you're going to mark. 1 mark for formula. Okay, any of the two is 1 mark. Any of the two that is written correctly is 1 mark. Then the substitution on the left hand side, all of it must be correct. All the numbers should be correct. If you chose the opposite direction, this will be positive and this one will be negative. Then another substitution on the right hand side, all of it should be correct. Now this answer is marked separately, then the direction is marked separately. Excuse me. This is 4.2.1. Done with 4.2.1. Now 4.2.2. Calculate the magnitude of the impulse on ball P during collision. So we have to remember the formula for impulse. Formula for impulse is impulse equals to, now let's think what is given to us. Impulse equals to F net multiplied by change in time, but we don't have F net change in time. So we allocate this impulse to equals to change in momentum. Just F net change in time. We don't have time. We don't have the net force also. So the quick way is to calculate the change in momentum of ball P. So this will be M V final minus V initial, and this is equals to the mass of ball P. The mass of ball P is 0.16, and final velocity of ball P is -5. We're still keeping the same direction where we chose right to be positive. -5 minus, from the formula, the initial velocity of ball P is 10, so it's just 10. You calculate here, you get so it's 0.16 multiplied by -5 minus 10, and you get -2.4 kilograms meters per second, or you can write Newton seconds, and that's the correct answer. You get marked this and that one. It's 3 marks. 1 mark for formula, 1 mark for substitution, 1 mark for the final answer. And just like that, you get 10 marks. Thank you for watching. I'll put one more video after this. Please check out my YouTube channel as well, and subscribe and like my videos. Thank you.